Let's start with the topic. Today we are going to talk about speed, okay, and the adjectives, the different types of speed. First, we start with what is speed. So, if you try to define speed, speed is nothing but it is the rate of change of distance. What is speed? It is a rate of change of distance. Means basically it is how much is the distance traveled by the body in 1 second. What is speed? Speed is nothing but how much the distance the object travels in 1 second is called the speed. That's why it is called as rate of change of distance. Means the how much is the distance traveled in a given time. That's why we use the word rate of. Whenever we use the word rate of, means we are talking about in a given time, in a particular time. Okay. So numerically, it is nothing but it is the distance traveled by the body in 1 second. What the speed gives us? Speed tells us how fast the object is moving. Exactly. If you want to know how fast any object is moving, you need to know its speed. Okay, so speed is nothing but it is a rate of change of distance, and it is in simple terms, if you try to understand how much is the distance traveled by the body in 1 second. Why we are talking about in 1 second? Because in SI system, the time is always calculated in seconds. Okay, so if you look at the uh, quantity, it is a scalar quantity. Our speed is a scalar quantity. Why is it so? Because when we say speed, we are not aware or we don't know the direction of motion. So that's why the speed comes out to be a scalar quantity. It has no direction associated with it. If you want to know the formula, the mathematical formula, speed comes out to be distance traveled by the body divided by the time in which the distance is being traveled. So the fundamental formula is speed is equal to distance upon time. This formula of speed is equal to distance upon time is said to be the first formula of physics. Okay, and the credit goes to Galileo for deriving this formula. Okay. The SI unit is meter per second and the CGS unit will be centimeter per second. So simple to understand. What is the SI unit of distance? Meter. And what's the unit of time? Second. So that's why the SI unit is meter per second. What is the CGS unit of time? Centimeters. And of of distance, centimeter. Of time, second. So the CGS unit is centimeter per second. Now how we represent it? So it is generally represented by the symbol v. Small v is used to represent velocity. And if you look at the symbolic representation of speed, then v is equal to s by t, where capital S is for distance and small t is for time. So this is some basic idea about speed. Now what we will do? Now we will try to understand the different types of speed. Okay, speed is the distance covered by a body in 1 second, but there are different adjectives we have added to speed because there are different types of speed. Okay, so let's one by one understand the different types of speed. The first and the foremost example is uniform speed. Okay. So when we say the object is moving with a uniform speed, okay, now here the meaning of the word uniform means same. Uniform means same. So an object is said to be moving with uniform speed if it covers equal distance in equal interval of time. So such examples are the examples of uniform speed when the object covers equal distances. Whenever the object is covering equal distances in equal interval of time, we say that object is having uniform speed. Okay. The object is having uniform speed because it is covering equal distances in equal interval of time. Let's take an example of uniform speed. Look at this car. Now this car is at the beginning, at the beginning you will find the position of the car is here. Okay, how much is the time? 0 minutes. We have not started the timer and it is at 0 kilometers. Then we started the timer and we observed that after 1 minute, we saw that the car has covered 1 kilometer. So after a time interval of 1 meter, the distance covered by the car is 1 kilometer. After 2 minutes, again further 1 more kilometer means 2 kilometers. After 3 minutes, 1 more kilometer means 3 kilometers. So if you find out here, if the car is moving like this, where in every 1 minute it is covering 1 kilometer, means it's covering equal distance in equal interval of time, we can say that this car is moving with a uniform speed. Now try to understand one more very important aspect of uniform speed, that whenever the object is moving with a uniform speed, it is not necessary that the object has to move in a straight line. Let's take this example, that the car started its journey from here and then it took the turn, and it reaches. Okay. Now, after 1 minute, it is 1 kilometer here. After another 1 minute, 1 kilometer here. After another 1 minute, 1 kilometer here. And after another 1 minute, 1 kilometer. So this is 1 kilometer. This is 2 kilometer. This is 3 kilometer. This is 4 kilometer. And this is 1 second, sorry, 1 minute. This is 2 minutes, 3 minutes, and 4 minutes. Okay. Now, if even now, even if the car is moving on this track, now is it a straight line track? Is it a straight track? No. You'll find the track is curved. Okay. You'll find the track is curved. So what you will find? The track is curved, but still you will find that the object is covering one equal distance in equal interval of time. So even if the track is curved, you will find that the object is moving with uniform speed. Why? Because what is the necessary condition? The necessary condition for uniform speed is the object to cover equal distance in equal interval of time. It is not necessary, not at all necessary, that the object has to move in a straight line. Okay, it may move on any track, curved track, anything. As long as the object is covering equal distance in equal interval of time, we call it as uniform speed. Let's talk about non-uniform speed. Now, how we call an object moving with non-uniform speed? Or another term is variable speed. And the important keywords to remember is whenever the object covers unequal distance in equal interval of time. So whenever the object is covering unequal distances in equal interval of time, we call the object is moving with a non-uniform or a variable. Now the meaning of non-uniform variable is same. Okay, let's take this example. Now the car is here at 0 minutes, okay, at 0 meters, at t is equal to 0 seconds. So when we started the timer, it is at rest at 0 minutes. Now after 1 second, if you look at the time interval here, this is 1 second time interval, the object has traveled 4 meters. How much is the distance traveled? 4 meters. Then another 1 second, you find that the object has traveled total 6 meters, but in the second it has traveled total 10 meters. The object has traveled, but in the second it has traveled 6 meters. Okay. Then in the third second, the object has traveled in all 10 meters, but in the third second, it has just traveled 3 meters. In the fourth second, you will find the object has traveled in all 18 meters, but you will find it has traveled 5 meters. So if you see it little more carefully, you will come to know that here the object has traveled 4 meters. In the first second, the object has traveled 4 meters. In the second, you will find the total was 10, but in the second, it has traveled 6 meters. Okay. In the third second, you will find it has traveled only 3 meters. And in the fourth second, you will find it has traveled 5 meters. So you will find the object is traveling in each 1 second. The object is traveling unequal distances. The object is traveling unequal distances like 4 meters, 6 meters, 3 meter and 5 meter. So if the object is covering unequal distances, 4, 6, 3, 5, unequal distances, in equal interval of time, we say the object is moving with non-uniform speed or variable speed. Okay, so this is the condition for non-uniform speed or variable speed. Let's talk about another one, instantaneous speed. Now, what is instantaneous speed? This instantaneous speed comes into consideration whenever we find that the object is moving with a variable speed. Because whenever the object is moving with a variable speed, and we want to find out what is the speed of that object at that particular instance, at that particular moment, we call it as instantaneous speed. So the speed of an object at that particular instant is called as instantaneous speed. How do we find this instantaneous speed? We find the instantaneous speed by taking the distance traveled in a very short interval of time. We don't have to wait for 1 second to find out how much is the speed. We find it in a very short interval of time. Okay, if you look at your car, your vehicles, you will find that the speedometer of your car, the speedometer of your vehicles, actually it is flashing the instantaneous speed. When you are moving, when you are driving, and if you want to know at what speed your car is moving, at that moment, at that particular moment, what is the speed of your car? What you do? You look at your speedometer, and the speedometer is flashing the instantaneous speed. So instantaneous speed is nothing but the speed at that particular moment. How we calculate it? By taking the time interval very short. Then we have average speed. Now what is average speed? So average speed is nothing but it is the ratio of total distance traveled by the body to the total time of journey. What is average speed? It is the ratio of total distance traveled by the body to the total time of journey. Now in the average speed, you need to understand that whenever we talk about average speed, we need to know that we are taking the total distance and then we divide it by the total time of journey. In that time, it is not necessary that the object is at rest or is it moving. If the object is at rest, still we have to consider that time because it's the average speed. So average speed is nothing but it's a ratio of total distance to the total time of the journey. Remember, in average speed, we take the total time of the journey. Okay. So these are some of the adjectives. The formula for average speed comes out to be total distance traveled divided by total time taken. So these are some of the adjectives of speed. We have uniform speed, we have non-uniform speed, we have instantaneous speed, and we have average speed. Now we will talk about the very important term, that is velocity. Okay, now what is velocity? So if you start defining velocity, it is on the similar lines to speed, but with an addition of a point. So there is a very strong resemblance between speed and velocity, and the relation is the same as we have in distance and displacement. The same is the relation you will find in speed and velocity. So basically, a velocity of a body is nothing but it is the distance traveled per second by the body in a specific direction. So you will find here that if I say speed, so the speed was also defined on the similar line. The speed of a body is the distance traveled in 1 second. So the velocity is also the same. It is the distance traveled in 1 second by a body in a specific direction. So what is the additional words we are having in this definition? So the additional word is specific direction. Means what is velocity? Velocity is nothing but speed with direction. What is velocity? Velocity is nothing but speed with direction. Okay, so it is a vector quantity. Obviously, you can easily conclude that why it is a vector quantity, because whenever you say velocity, means you also know the magnitude of that motion, but along with knowing the magnitude of the motion, you also know the direction of motion. That's why velocity is a vector quantity. And what's the mathematical formula for it? So you will find the formula is displacement upon time. Whereas you remember speed is distance upon time, velocity comes out to be displacement upon time. Now the very important question you may be asking, that if velocity is a vector quantity, what is the direction of velocity? So the direction of velocity is the direction of displacement. So whatever is the direction of displacement, the same is the direction of velocity. So that's why we say velocity is displacement upon time, because the direction of the velocity, the direction of the displacement is actually the direction of velocity. What would be the unit? So we know the unit of displacement is meter and time is seconds. The CGS unit is also the same. The only thing we have to remember is how we represent velocity. So velocity is represented with a symbol V with the arrow on its head. V with the arrow on its head. So this is how we represent a velocity. Okay, V with the arrow on its head like this. Why? Because it's a vector quantity. But remember, we are having two terms to represent velocity. Okay, which are the two terms? So the two terms are u and v. Okay, so which are the two terms we have to represent velocity? We have u and we have v. Okay, you may ask, sir, why we are having two terms to represent velocity? Because whenever we talk about velocity, it is not necessary that the object is always moving with a same velocity. The velocity may change. So that's why there may be a difference in the velocity during the motion. So what we do, we use two terms, u and v. U is used to represent initial velocity and v is used to represent final velocity. So that's why we are having two terms to represent velocity, that is u and v. Now we will look at some more adjectives of velocity. The first and the important adjective is uniform velocity. Now what is the condition for an object to be moving with uniform velocity? So the first and the important condition is it should cover equal distance in equal interval of time. But the most important condition is in a particular direction. So these are the three things what the object has to fulfill, the moving object has to fulfill to be called as moving with uniform velocity. Which are the three terms? The three conditions. The first is it should cover equal distance in equal interval of time and in a particular, in a specific direction. So let's take this example now. The car is moving. The car is at rest when we started the timer. After 1 kilometer, it has traveled. After 1 minute, it has traveled 1 kilometer. After 2 minutes, it has traveled 2 kilometers. After 3 minutes, it has traveled 3 kilometers. Means in every 1 minute, the car is traveling 1 kilometer. Exactly. Because here it's a time interval of 1 kilometer, here time interval of 1 kilometer. Sorry, the distance of 1 kilometer, the distance of 1 kilometer. So you will find that this motion of the car is said to be moving with uniform velocity. Why? Because the car is covering equal distance. How much is that equal distance? 1 kilometer each. So the car is covering equal distance of 1 kilometer in equal interval of time. So this is covering equal distance in equal interval of time, but the most important part is that this car has to be necessarily moving on a straight line, on a straight path, on a straight road. Getting it? Why? Because the direction of this motion has to be, the direction of this motion has to be same. So you remember when I discussed uniform speed, I told you that it is not necessary for the car to be moving in a straight line for uniform speed. As long as the car covers equal distance in equal interval of time, we say the car is moving with uniform speed. But for uniform velocity, it has to cover equal distance in equal interval of time. But along with that, the car has to move. The car has to move in a straight line. So the car is necessarily, compulsorily moving in a straight line only. Okay, so this is the very important condition the car has to fulfill. If the car is changing its direction, then we cannot label it as uniform velocity, even though the car is covering equal distance in equal interval of time. The third and the important point what the car has to fulfill, the object, the moving object has to fulfill is it has to cover equal distance in equal interval of time in a specific direction, because we're talking about uniform velocity. Next, non-uniform velocity. Now, what is the condition for non-uniform? So there are two conditions for non-uniform. Okay, the first is there are two definitions I can say there are two definitions for non-uniform velocity. The first is that if the object covers unequal distance in equal interval of time, in a particular direction. When the object covers unequal distance in equal interval of time in a particular direction. Let's take the example. This is the example of non-uniform velocity. How? So this car is moving. Understand? This car is moving on a straight path. The road is straight. This is what we have assumed. So the road is straight. But if you look at it, it's covering unequal distance. Okay. In the first second of its journey, it has covered 4 meters. In the first second of its journey, it has covered 4 meters. In the second of the journey, 6 meters. In the third second of the journey, 3 meters. And in the fourth second of the journey, 5 meters. So you will find it is covering unequal distances in equal interval of time. So this motion is non-uniform velocity. But we have one more example of that, and that is this motion. What is the condition for that motion? So we say the object is moving with non-uniform velocity if it covers equal distances. If it covers equal distances in equal interval of time. Yes, so you'll find it's covering equal distance in equal interval of time, but its direction of motion is not the same. So what is not same? The direction is not same. The direction of motion does not remain the same. Such motion is said to be non-uniform velocity. So look at the example. Now where is the object? So the object is here. Where is the object? So the object initially is here. Okay, that started its journey, and after 1 second it reaches here. After 1 second it reaches here, and then after 2 seconds it reaches here. After 3 seconds it reaches here, and after 4 seconds it came back to the initial position. So you will find that the object in every 1 second is traveling 10 meters, because this distance is 10 meters, this is 20, this is 30, and that's 40. So the object is covering equal distance in equal interval of time. How much is the distance covering in the first second? 10. In the second, 10. In the third second, 10. In the fourth second, 10 meters. So you will find the object is covering equal distances in equal interval of time. But there is a problem. And what's the problem? That its direction is not constant. Look at the direction look at the direction at 0 second. The direction is already been shown here with the arrow. So this is a direction of motion. But after 1 second, the direction has already been changed by 90 degree. Another 1 second and the direction is again further changed by 90 degree. And again, the direction is being changed by 90 degree after 1 second. So what we conclude that every moment the object is changing its direction. There is a change in direction. So this is not an example of uniform velocity. This is an example of non-uniform velocity, even though the object is covering equal distance in equal interval of time, but since the direction is changing, we called such motion as non-uniform velocity. Is it an example? I'm talking about the second case. Is it an example? I'm talking about this case. Is it an example of uniform speed? And the answer is yes. This is an example of uniform speed. Why? Because the object is covering equal distance in equal interval of time. The speed is not related with direction. So that's why even the object is covering equal distance in equal interval of time, it is okay that to declare that object as moving with uniform speed. So this is an example of uniform speed, but it is not an example of uniform velocity. It is an example of non-uniform velocity. For an object to move with uniform velocity, it has to fulfill three conditions: equal distance, equal interval of time in a specific direction. Now, next is instantaneous velocity. Exactly. So the same is the definition. Whenever the velocity on an object is changing, that its velocity at any instant, at any moment is called as instantaneous velocity. Again, how we calculate the instantaneous velocity? We take the time interval very short, and along with that, we have to make sure that during that time interval, the direction is not changing. So that's the care we have to take to find out instantaneous velocity. And then we have average velocity. So what is average velocity? It is slightly different than average speed. It is the ratio of displacement of the body to the total time of journey. Exactly. If you recollect what was average speed, it was total distance upon total time. Here it is displacement upon total time of the journey. So average speed becomes displacement upon total time of the journey. Clear, class? I hope you are quite clear with these adjectives of speed and velocity. Now what we will do, we'll quickly look at the difference. Wait a minute, I think we have some. Okay. So now we will quickly look at the difference between speed and velocity. Chalo, let's start with the difference between speed and velocity. So what is the difference? What's the fundamental difference between speed and velocity? So the distance traveled per second by a moving object is called speed, whereas velocity is the distance traveled per second by a moving object in a particular direction. That's what I was trying to highlight you all, that here whenever we say velocity, we add one more term to it, and that is in a particular direction. So whenever the object is, when we talk about velocity, it is nothing but the distance traveled per second in a specific direction. Another important thing about speed, it's a scalar quantity it's a scalar quantity, whereas velocity is a vector quantity. What is the interesting thing about velocity? It tells us the speed, as well as the direction of motion. Then one more important thing about speed, that speed is always positive since there is no direction considered. But velocity is positive, no problem, but it can be negative as well. You remember I told you something about vector quantities. So a velocity of an object can be negative since it's a vector quantity, and in vector quantities, the negative sign indicates the opposite, the reverse direction. So if the direction is opposite, then the velocity comes out to be negative. And next, in one round in a circular path, the average speed is not zero. We have taken the previous example. Assume the object is moving on that circular path. So in one round of circular path, what will be the average speed? So average speed will be total distance upon total time. Total distance was 40 meters and total time was 4 seconds. But after one round in a circular path, the average velocity is zero. Now you may be wondering how the average velocity becomes zero. Because remember class, average velocity is displacement upon total time. And in one circular path, how much will be the displacement? The displacement will be zero. Why? Because the object started from the same point. The object started from a point and it comes back to the same point. So the initial and the final position is the same, and that's why the displacement is zero. So what will be the average velocity? So the average velocity will be zero because average velocity is displacement upon time. Okay, so this is a very fundamental difference what you should know about speed and velocity. Yes, but Avni, if the object travels on a semicircular path, then its average velocity is not zero. Why? Because in a semicircular path, the displacement is not zero. Very good, Avni. The displacement is not zero, and that's why the average velocity will not be zero. It will be only in one round. Remember, I have mentioned it very clearly that in one round, okay, in a circular path. If half of the round is there, or third, fourth of the round is there, or 1/4 of the round is there, then the average velocity is not going to be clear, class. I hope your idea is very clear between speed and velocity. Chalo. So now let's start with another very important term. Write down the name of that term, and the name is acceleration and retardation. Very good. Thank you, beta. Om. Thank you very much. You are responding very well, beta. Keep on doing like this. Okay, keep on responding to me so that I will come to know. Avni and Om, both of them are responding. Very good, beta. Okay. Chalo, now let's start with another very important term, and that term is our acceleration and retardation. Now, what is this? This is something which is new to us. This is something which I am using. I might have used it earlier in 8th standard, in the lower classes. You must have heard about this word acceleration, but now officially we are going to understand what is acceleration. Let's start with the discussion of acceleration. When this condition comes into consideration. So whenever a body moves, basically most of the time you will find that the velocity of the object is changing. Okay, understand? Whenever the object is moving, most of the time you will find, even you go for a walk and you will find out that you are not covering equal distance in equal interval of time in a specific direction. Okay, so your velocity keeps on changing. So whenever the body moves, there is a change in the velocity of a body. And this change in velocity can be either due to the change in speed or due to the change in direction. Understand when the change in velocity takes place. So the change in velocity takes place due to two things. it changes due to the change in the speed. Whenever the object is changing the speed, we say there is a change in velocity. Change in the speed means if the speed increases with time or the speed decreases. So whenever the speed increases or decreases, we say that there is a change in speed. But it is not necessary due to the change in the speed. It can be due to the change in direction. So when a body moves, there is a change in the velocity. And what is the reason for change? It may be due to the change in speed. The speed is increasing with time, or the speed is decreasing with time, or due to the change in direction. For example, you are sitting in a car. You are in a car and you are moving. Okay. So whenever you press the accelerator, or your dad is pressing the accelerator and you are observing, so you will observe very carefully. If you are observing very carefully, you will come to know that whenever your dad presses the accelerator, you will find that the speed of the car increases. And whenever he presses the brakes, whenever he applies the brake, the speed of the car decreases. So whenever the speed of the car is increasing or decreasing, you have to understand that the velocity is changing. Even whenever your dad rotates the steering of your car, whenever the steering of the car is being rotated, you will find that will result in the rotation change in the direction of the car, and even that is change in velocity. Class, I hope you are getting it, that the change in velocity is due to two things. It is due to the change in speed, or it is due to the change in direction. Okay. Now, let's take an example, a moving vehicle in a busy market. Okay. So, but now in this topic of our discussion, because you know our discussion is limited to motion in one dimension. What's the name of our chapter? Motion in one dimension. And I told you in the beginning itself that what is the limitation of our discussion? The limitation of our discussion is that the object is moving in a straight line. So obviously when the object is moving in a straight line, there is no change in the direction. Yes, so we can say what is the cause of change in velocity? The cause for the change in velocity will be only the change in speed. Getting it, class? What's the cause of change in velocity? The cause of change in velocity will be the change in speed only. Why? Because the limitation of our discussion is motion in one dimension. If you discuss motion in two dimension, then what will be the cause of change in velocity? It may be the change in speed and change in direction. But in our syllabus, we are only going to talk about the change in velocity is due to the change in speed. But it does not imply that the change in direction is not considered. The change in direction is there, but since it's motion in one dimension, so we limit our discussion to a straight line motion, and in straight line motion, this direction will never change, and that's why whenever we say acceleration, so acceleration will always be related to the change in speed only. Okay. In such cases, if the velocity of the body increases with time, okay, now obviously, if the velocity of the body increases, we call it as acceleration. And if the velocity of the body decreases, we call it as retardation or deceleration. What we called it? We called it retardation or deceleration. Okay. Now, we will go ahead with the definition. So what is acceleration, bachcha log? This is the definition of acceleration. Very simple and straightforward. Acceleration is rate of change of velocity. What is acceleration? Acceleration is the rate of change of velocity. So you will find there are two terms. You will find there is rate of, and then we have change of velocity. These are the two terms. Now, when we say rate of, I told you in the previous discussion as well, when we were defining speed, I said you rate of means in a given time, in a given interval of time. So what is acceleration? Is nothing. It is not only the change in velocity, but it is the change in velocity in the given time. Okay, means how much is the change in velocity taking place in 1 second, because we measure time in seconds. So acceleration is nothing but the change in velocity in 1 second. Exactly. So numerically, acceleration is equal to the change in velocity in 1 second. That is how you have to understand acceleration. How much is the velocity changing in 1 second? Now let's frame it mathematically. So acceleration is rate of change of velocity, means how much is the change in velocity taking place divided by time. So acceleration is change in velocity upon time. Means how much is the velocity changing in a given interval of time. So if you look at the relation, it will come out to be the change upon time. So how we represent acceleration? So we represent acceleration by the symbol A with the arrow on its head. Now what does that indicate, an arrow on its head? It indicates that it's a vector quantity. So my acceleration is a vector quantity. Now the moment I say vector quantity, it has direction. So the question that will come to your mind, sir, what is the direction of acceleration? So the direction of acceleration is the direction of velocity. Then you will ask me, sir, what is the direction of velocity? So the direction of velocity is the direction of displacement. So it's very simple. Whatever is the direction of displacement, that's the direction of velocity. And whatever the direction of velocity, that's the direction of acceleration. So it is represented by the symbol A. Now we are going to find out how we calculate mathematically, how we represent change in velocity. So let's take u as a term for initial velocity and v as a term for final velocity. If you remember, I told you velocity is represented by two symbols, that is u and v. So how much will be the change in velocity? Let me give you an example. Okay, assume that a car is moving with a velocity of 20 meter per second. What's the velocity of the car? 20 meter per second. And after a given interval of time, it reaches to 45 meter per second. How much is the velocity it acquires? 45 meter per second. Now, can you say me how much is the change in velocity? So you will say, so the change in velocity is 25 meter per second. How you calculated 25? You have done it by 45 minus 20. So the same thing what we have done here to find out the change in velocity beta, what I have done 45 minus 20 means v minus u. So how we calculated change in velocity? Very good, Om. How we calculated change in velocity? We calculate change in velocity by final velocity minus initial velocity. So that's why mathematically, if I want to represent change in velocity, it will come out to be v minus u. So my acceleration will be a, change in velocity will be v minus u divided by t. So what's the formula we have for mathematical formula for acceleration? Acceleration is mathematically written as v minus u upon t. Remember, this is a very important formula. We have required it every now and then. So acceleration is equal to v minus u upon t. Now what is the unit of acceleration? Very interesting. The unit of acceleration is very simple. In physics, you want to find out the unit, look at the formula and put the units of the factors in the formula. So what is the unit of acceleration? It will be the unit of velocity divided by the unit of time. What is the unit of velocity? Meter per second. What's the unit of time? Divided by second. So meter per second divided by second, you will find that the second will not get cancelled. Be very careful. It's meter per second divided by second. You will find that it comes out to be meter per second square. Okay, please understand the maths be there. You will say, sir, ye s or ye s cut ho jayega. Nahi honga, it is in division. Okay, should I explain you that? So let me show you very quickly. This is meter. I'm so sorry. My mouse has to work very smoothly for that. So this is meter upon second divided by second. Okay, so this is divided by second. So we know that anything it is divided by 1. So what we get then? So it will be meter per second into it's a division. I take the multiplication. So I convert it, I multiply instead of dividing. So I will take the reciprocal of this. So it will come out to be 1 upon second. So what we get? We get meter second square. I hope you are getting it. I'm sorry for that, but I'm using my mouse for that. So what's the velocity? What will be the unit? The unit will be meter per. It will be meter per second square. Om, are you clear, bacha? Because you said it will get cancelled. I've just explained you. Om, give me your response, beta. Are you clear or should I explain it again? Not get cancelled. That's what I'm saying. They will not get cancelled. Very good. Okay, it will not get cancelled. Chalo. So that's the unit of acceleration. Now understand when we call it acceleration and when we call it retardation. So we call it acceleration when v is greater than u. Understand this relation. Now what does this mean? V is greater than u. V is greater than u means my final velocity is more than the initial velocity. Means with time, my velocity is increasing. Assume my initial velocity is 10 and my final velocity becomes 40. So my final velocity is more. So when my final velocity is more than the initial velocity, if you give a logical thought to it, you will come to know that the velocity or the speed of the object is increasing with time. And then you will find your acceleration is positive, and we call that phenomena as acceleration. Okay, we call that phenomena as acceleration. But if your v is less than u, means your final velocity is less and initial velocity is more. Assume we are moving with the initial velocity of 10, and after 2 seconds or after a particular interval of time, your velocity becomes 2. Means what is your initial velocity? 10. What's your final velocity? 2. So what has happened to your motion? Has it increased with time or has it decreased with time? Has the velocity increased with time or decreased with time? So you will find the velocity is decreasing because your initial was 10 and the final is 2. So your velocity is decreasing, and then your acceleration will be negative, and it is called as retardation or negative acceleration or deceleration. These are the three terms to name that phenomena whenever the velocity is decreasing with time. Which is that phenomena? Either you call it as retardation, you call it as negative acceleration, or you call it as deceleration. So I hope you understand what is acceleration and what is retardation. Acceleration is when the speed increases with time. And what is deceleration? Whenever the speed decreases with time. So that is called as deceleration. Is it very clear, class? Just say me yes or no. Just type yes or no in the chat box so that. Okay, chalo. So I will stop sharing this because I want to show you exactly what is acceleration and retardation. Okay, so I will share something with you. Wait a minute, class. I'm sharing something with you. Okay, now look at this. I'm sharing. Look at it. Now this is the motion. Now, wait a minute, wait a minute. I will share something more. This is what I want to share with you. Look at it now. This is a box which is lying, which is kept on a trolley. And now what we will do, we will apply the force. Okay, so now we are not interested in that. We are more interested in the speed part of it. Okay, and understand class, this track is a straight line track. Okay, this track is not a zigzag track, it's a straight track. So obviously whatever will be the change in velocity, it will be only due to the change in speed. Okay, now look at it when we apply the force. See, we apply the force, and as soon as we apply the force, you see the force is being applied, and what happens to the speed? Look at the speedometer. Look at the speedometer. What's happening to the speed? You will find that the speed of this object is continuously increasing. The speed, you can refer it with the background as well, that the speed is continuously increasing. What such type of motion is called as where the speed is continuously increasing? We call this motion as acceleration. Okay, now I will not apply any force. Okay, now am I applying any force? No. So what is this type of motion? Now this type of motion is called as uniform speed or even uniform velocity. Why? Because the object is, look at the speed. The speed is remaining constant. The speed is not changing. So what is this example now? This is an example of uniform speed. Now I will apply the force in the opposite direction and look at the speed. What's happening to the speed, class? What's happening to the speed, class? The speed is decreasing. See, look at the speed. The speed is continuously decreasing with time. Exactly. So what is this? This is uniform. This is retardation. What is this? This is retardation. Understand what is acceleration and what is retardation. I will again show you. I am going to show you three types of motion: accelerated motion, constant velocity, and retardation. Okay, so I apply the force. Look at the speedometer. I apply the force and see the speed. See how fast the speed is increasing with time because the speedometer is showing. Okay, so what is this now? You will find the speed is continuously increasing with time. So this is my acceleration. Now, what is this? So look at the speedometer and you will come to know what's happening. Is it accelerating? No. Then it's moving with uniform velocity. So this is uniform velocity. Now I apply the force in the opposite direction and see. What do you find? Look at the speedometer. Look at the speedometer. And what you find that the speed is decreasing with time. See, the speed is decreasing with time. The speed is decreasing with time, and you will find this motion is retardation. I hope you are getting what is acceleration and what is retardation. What happens in acceleration? In acceleration, the velocity is increasing with time. And what's happened in retardation? You find that the velocity or in motion in one dimension, the speed is decreasing with time. All of you, are you getting it better? What is acceleration and what is retardation? Please respond. I hope all of you are getting it, that what is acceleration and what is retardation. In acceleration, you find that the velocity is increasing. See, the velocity of the object is increasing. Look at the acceleration. The velocity is continuously increasing. Okay, so this is called as acceleration. And what is this? Now this is constant speed or constant velocity, because the speed is not changing. It's not that the object is at rest. The object is moving at a constant speed. So the speedometer is not showing any change in the speed. And what is this? This is our retardation. What is this? This is our retardation. See how the velocity is decreasing with time. See how the velocity is decreasing with time. Okay. So what is this? This is our retardation, where you will find the object comes to rest. This is our retardation. All of you, are you getting it? What is acceleration? What is retardation, bachcha log? I want your response. I'm waiting for your response. Okay, chalo. Thank you very much. Okay, so what we concluded, we have just seen what is acceleration, what is retardation, and more importantly, we have seen how to what is the mathematical formula for acceleration and what is the unit of acceleration. Clear class? All of you? Is it very clear? Okay. So I have to stop my session now. Okay. So I will stop this session. Okay.